So, hello everyone. I'm conscious it's very hot. Thank you for staying and being entertained, hopefully. And I'm also conscious this is the sort of mid-afternoon kind of death shift. So if anyone is awake by the end of this, then I'll think you have sort of chronic insomnia. But in the meantime, I'm going to gallop through a few thoughts on doing AI at scale and moving away from endless proofs of concept to what does it take to actually roll this out across large, complex organizations. And then I'm going to invite on stage a few friends and distinguished speakers from Google and Heidrick, from Lloyds Bank, and from Microsoft to discuss these topics a tiny bit further. So, without further ado, what are we doing? So I'm going to cover four things in this brief keynote. One is who we are as Quantum Black and what we do, so you have some sense of where I'm coming from with these perspectives. Second being, when we talk to clients, to prospective clients, to folks in government, to people that we meet, what do we hear? What are some of the common challenges around this? I'll outline a few thoughts on our approach to respond to these challenges, and then just one final thought in closing. So firstly, who are we and what do we do? So as Quantum Black, we partner with big organizations, governments, corporates, third sector organizations to try and deliver AI technology in the wild, in the real world, to address some of these challenging opportunities that these organizations have. And the way that we try to get to scalability is very much through the approach that we take that I'll elaborate as we go through. And we're big on building capabilities as well. So we've been around trying to do this in the wild for 10 years, and I'm not trying to present that we have all of the answers today. I think this is very much something that's going to be in evolution for a while. But we've got 10 years worth of what I call scar tissue to share and to reflect on with you today. So to try and bring that to life, I'm going to try and talk a little bit about how our work has evolved over 10 years through the lens of the work that we've done with various parts of Formula One over 10 years. So to some extent, sticking with a sporting theme. This is an example of a project we did back in 2009 with one of the Formula One teams. And you can see a page that has lots of dots on it. And what the dots are, each dot is an R&D project that's working on a part for the car. And up and down the chart, you have a sort of synthetic KPI, which is interconnectedness. How much does this part affect other parts? If you change the shape of the rear spoiler on the car, that's going to affect everything else, and so on. And across the page on the x-axis, you have a measure of communication intensity, which is another synthetic KPI based on email traffic, metadata, phone records, calendar, SharePoint, all of these types of collaboration. And we can see that there are, in the top left, a bunch of sort of lone wolf teams who are not really talking to anyone, even though their parts are very connected. And we can see in the bottom right, there's people who are just making noise in the system. So what do we do with this? So this was probably one of about 40 or 50 different angles that we took on this question of how could we make the R&D process more effective. And some of those included how we put teams together. Some interesting things came out of the analysis, like the difference in age between the principal engineer and the other engineers on the team, which kind of start getting to, is this just a random correlation or is there actually something happening here? And so you can start to design experiments to see if we consistently put teams together in this way, do they perform better? And it turned out they did. So we never really got to the bottom of why that was happening, but we kept on building that in. And so effectively, you sort of reverse engineer all of these insights into actions that the business can take. So if we go to the next year, the next season, same team, same data set, we can see that people have changed their behavior. Something has changed here, and even for those who haven't, let's see if the laser works. Does the laser work? That's optimistic. So there's a dot in the top left corner where you can actually go and have a conversation with the guy or woman who's leading that team and say, did you not get the memo? Because everyone else seems to have got on board. So that behavior change then translates into performance gain. The metric here is a technical ratio called CL points, which is a measure of downforce ratio over drag for a car, but that translates into seconds around the track. So we can see that that behavior change, among a bunch of other behavior changes, has led to an increased sort of rate of learning and of improving across this. So that was kind of 2009-10, static data sets, ingesting them, linking them together, wrangling them, building models that are basically explaining what is going on, what happened historically, deriving insights from that, and then manually coming up with interventions that we can take on the back of those insights. So if we fast forward to 2016, another thing that we've done in this space was a predictive application for the commentators for Formula One. So this is data as entertainment and is now forward-looking rather than backward-looking. So a lot of the foundation of the whole Formula One system is whether lots of people watch it on TV. And one of the things that helps drive up the numbers is when the commentators have something interesting to say. So this was an app that was, I don't know if it's clear on the big screen, but the top thing there is Hamilton is about to overtake. In one of the sidebars, there's a risk of gearbox failure. And so this allows the commentators to say, oh, you know, I think that Hamilton might be about to overtake here in the next kind of minute or two, and keeps everyone on the edge of their seats. We then boiled that down to a smartwatch app that would just vibrate when something interesting was going to happen, and then that would alert the commentators to be able to say something. And so I put this up partly just because it's a cool picture and, you know, it's a smartphone and it's a cool app, but also because a lot of what we're trying to do with this forward-looking technology is just simplify all of the complexity around all of these different data sources, all of the different models that are running in the background, and just give the right information to the right human being at the right time to allow them to then do their job better. So very much focused on this point around augmented intelligence, trying to create tooling that helps humans do better. To bring that right up to date, this year, the most recent thing that we've done, the gods of technology are on our side, the video is even going to play, is solving what seems like a pretty trivial question, which is, where is the car on the track? But when the car is moving at 300 kilometers an hour, and it takes GPS about 5 seconds to go up in space and come back again, and GPS is kind of plus or minus 5 meters, which tells you whether the car is either on the track or it's killing 2,000 pedestrians. It's a tough challenge. And so I'm going to see if this pauses. Is this going to pause? It's going to pause. Okay, here we go. So the question was, how could we do this? And for me, this is an example of now in 2018, we just live in this kind of age of marvels. And the way that we came up with to answer this question was put a bunch of high-def cameras around the track, 1,000 frames a second, and use a machine vision algorithm to identify which car is which, and then triangulate the position of the car against other landmarks around the track. And you can in a thousandth of a second, get to a 20 centimeter, sort of plus or minus 20 centimeter location of the car, which then allows you to do things like real-time racing in computer games. So, you know, a computer game participant can race the real drivers during the real race in the real position. So it unlocks all sorts of other kinds of activities. So, of course, we're not just working in Formula One. We do a bunch of stuff in other areas, probably about half our work is in pharma and healthcare, a bunch of stuff in other advanced industries like automotive, mining, energy, and so on, telco. We do a lot in financial services and so on, and we're still working in sport. So we do football as well, and baseball, basketball, a real mix. So that's kind of us and who we're coming from. And so a lot of my role involves flying around the world talking to people who are interested in doing this kind of stuff or applying these kinds of technologies to solve big problems they have or to capture big opportunities that they have. And so we hear a lot of people kind of reflecting on how to do this at scale. And so the first point, before I slightly take the piss out of everyone, is that, like, let's be fair, this is really, really hard. And so we shouldn't doubt that. One of the CEOs at Davos this year came out with this quote, which I loved, which was, this was not Lufthansa, it was another company, but he said, we seem to have more pilots than our friends at Lufthansa, because it's just very difficult to get beyond the pilot stage. We've got a couple of PhDs, we've got an interesting area, but how do we actually get this to land? And there are all sorts of good reasons not to do this. I was struck, the BBC published a poll recently about hiring senior women, and this is a sort of momentary diversion. But people came up with all these reasons why they weren't hiring senior women. I don't think women fit comfortably into the board environment. This is 2018, people, right? This is not 1970, okay? Most women don't want the hassle or pressure of sitting on a board. You know, all the good women have already gone, right? Sort of, what are you talking about? Okay, so these are really bad reasons to not do stuff. And for us, the same is often true of the reasons that people give for not doing AI at scale. There's always an interesting excuse, right? That's all very well in F1 or in banking or in pharma, which is basically anywhere that's not here. But we're not ready for this whole kind of AI rocket science stuff. We just need something really basic. Okay, that's like bad excuse number one. Or just something incredibly aspirational but totally meaningless. Like, we want our organization to be AI-led. Like, great, what does that mean, right? Sort of, who cares? I would love a bunch of stuff. Or we'd love to do something in this space, but we've got to hit the numbers this quarter. That's got to be our principal focus. So why don't we do a POC and a proof of concept, and we'll sort of kick it into the long grass. We have this one a lot. We hired some really smart PhDs, but they didn't really do anything. And so we've tried it. It didn't work. It's not for us. And so what we often find is that we have a lot of smart data scientists, PhDs in Quantum Black, right? They're amazing at building models. They're amazing at computer science. They're typically not amazing, and they don't really enjoy organizational politics, running workshops, doing change management, having really difficult conversations with people. And a lot of that stuff has to happen if anything is going to change in a large organization. So the idea that you can just hire a bunch of smart data science PhDs and magic will happen is kind of delusional, we find. Another classic is people are just too busy on the day-to-day. And one of my favorites is we have tons of data. Before we do anything else, can't we just fund an AI program by monetizing our data? And so this is a bit like the sort of we want to be AI-led aspiration. It's like we want to make loads of money because we have data aspiration. And which is equally, sometimes once in a blue moon, you just have amazingly valuable data that you can sell to people, but very, very, very rarely, right? And then the final one is the Ocado approach, or like the penultimate one. So this is a guy ordering something on his iPad. We want some AI. How much can you deliver? Or we want some machine learning. Like, we'll take sort of 3 kilos of machine learning, please. And so all of this for us is kind of putting the cart before the horse, so to speak. And the final one, I promise, is we're empowering the business units and the teams to do their own thing and to experiment. We want to be entrepreneurial. This shouldn't be central planning. This is not Comintern. This is what we're doing. So the spoiler alert for that one is that 1,000 flowers don't bloom. We've never seen any large organization decentralize this, hope for the best, and suddenly they're doing AI at scale. It's like, maybe it's happened somewhere and I've never come across it, but it's we've never seen it. So, rather than just sort of gently mock people, what would we suggest that we actually do? So what's our approach? I'm going to talk a little bit first about the what, and then the how. So the first point, and this sounds like one of those sort of bleedingly obvious points, until you bear in mind all of the quotes that we've just heard, is actually start with value. So don't go anywhere else until you've figured out what you're trying to achieve. And that could be a commercial value, it could be a bottom line number, it could be a time number, it could be a cost number, it could be an outcomes number like patient safety, or a social outcome like we want to identify and take care of people who've been victims of human trafficking. But start with value. Only then think about data. Okay, what data ecosystem can we build that is going to help us understand the metrics that we need to shift to perform better on this value? Then think about modeling, then think about the actions you can take. And ultimately, this is about culture. Like, we achieve that sort of lofty aspiration of we want to be AI-led when actually this seeps out into the culture of the organization. Just on this point about value, this was a sketch from a recent workshop that we did in pharma, where we just said, right, let's lay out the whole value chain. There's R&D, there's development, there's manufacturing, there's commercial, there's RWE is real-world evidence in pharma. Then there's a bunch of enablers. And just have a conversation about what do we actually want to achieve with this before we go any further. So how do we then do this? We have what we like to call the simple formula for success, which, if there are mathematicians in the audience, will recognize this. No, sorry, this is a bad joke. That's not our simple formula for success. Our formula for success is about 4 areas I'll touch on briefly, which is people, tech, process, and protocol. Someone was saying to me earlier, the second one should be a P as well, and then they're all Ps, but like, whatever. You could say platform, but then it's actually not all about platform. So I'll talk first about people. This is what a typical team looks like at Quantum Black. We've got our head of platform engineering, a UX designer, a sort of project manager, a data engineer, another UX designer, a machine learning engineer, a data engineer here, and just the ear of our CTO, Sam. But the point about this for us is that it really takes a village it takes a village to raise a child, it takes a village to raise an AI, right? And that this mixing of interdisciplinary skills and different backgrounds is actually really important. We need someone who has an anthropology background to sit with the people who are going to be using this tech and understand their life and how this technology is going to fit into it and why they should make different decisions or how they can make better decisions or why they should do something differently in the future. We need someone who can push a mathematically complex model that one of the data scientists has built into streamlined production in a sort of cloud environment. You know, we need all of these different skills coming together. And because of that, and because we live in such an overheated talent market, talent value proposition becomes a really big thing. It's a big thing for us. It's a big thing for all of the clients we work with. It's a massive issue in government. It's a massive issue in a load of emerging economies. How do we attract and retain and develop and excite the talent in this different space? So this is some random snapshots from the Quantum Black Instagram page, which is very much about trying to communicate the culture that we have around it's Pink Day for diversity and everyone's having cake, or we're speaking at conferences, or we've just been used as a case study, or whatever. I get now approached the whole time by branding consultancies who are saying, do you want to brand your engineering team? And I'm like, wow, I don't know, maybe, but this is a thing, right? And I don't know if the answer is to brand your engineering team, but definitely the answer has to be about what is our talent value proposition and why should people care? A big part of that is also around diversity. So I wrote a piece recently, which I won't go through now, but around why diversity is not just a sort of ethical issue, but actually it's a performance issue. Diversity of people, diversity of data, diversity of modeling techniques. All of these elements of diversity are critical to actually doing this at scale. And ultimately, the boring old thing is still true. It's always about leadership. There are a million brick walls that we need to run through in order to do this. These are the mountains in Elephant Island in Antarctica where Shackleton successfully got all of his people through. So hopefully it'll be slightly warmer, but that level of leadership is also important. On the tech front, massive issue here, right? And we could talk about the right enterprise architecture for AI all day. I would boil it down to one big decision that most organizations need to make, which is, do we want to get into bed with a major platform provider, like a Palantir and Azure and AWS or whoever, or do we want to actually try and build this ourselves in-house? We've seen a lot of people struggle to do this. It's really difficult. It's really difficult to find enough DevOps engineers who are really good at this. It's really difficult to retain them and so on. But who are sort of slightly nervous about the whole, do we want to form a long-term partnership with a single provider? We would say just find a way of making that choice and then kind of go for it. But ultimately, this whole stack has to be in place, right? Around, we have to understand what we're doing. We need to have data which fits into a kind of semantic model of what we're doing. We need the analytics. We need a front-end surface that people can interact with. And then we need to take actions on the back of that. So whatever technology is going to allow you to go for that full stack, you need to have in place. And otherwise, this thing is not going to work. We also hear a lot, well, yeah, but analytics and machine learning, isn't it all commoditized? I can just download a random forest model off the internet. Why do we need data scientists anymore? This whole thing's commoditized. We'd be like, be pretty careful here. We find that almost all of the challenges that we're solving in this way, we're coming up with completely novel approaches each time. Or if we're not, we shouldn't be doing it. Final quick thoughts on the process. So we have this thing that we call the 5 I's, where we start with ideation. What question are we trying to solve? Then we go into intelligence or sort of due diligence. Let's DD the data. Let's DD the analytical approach before we do anything. And then we have a pretty hard stage gate where we say, do we think there's a there? Are we trying to do the right thing here? Inception is then kicking off the modeling and the full ingestion and so on. Interventions, pushing it through into production. And independence about building those capabilities to continue to do this over time. And that is a fully iterative process. It's never waterfall. No matter how many PowerPoint charts you do, no matter how many Gantt charts there are, they're all wrong. And the only way that we've found to do this is to accept the fact that they're all wrong, just kind of internalize that, and move on from there. And we really try to think about this kind of VC mentality to keep on investing in each every 2-week sprint and keep moving on. And so that gets us ultimately to what we call our protocol, which is kind of our way of doing this. And we kind of back that up with technology. So a final thought, I'm sure many of you will have seen the Shia LaBeouf video on YouTube. Watch it again. And the one-line answer to how do we do AI at scale is just do it. There's a line from a movie, oh, how do you fall in love? You just fall in love, right? How do you do AI at scale? You just do AI at scale. But unless you do it today, it's never going to happen.